We built an interactive visual testbed system for dimension reduction and clustering in a large-scale high-dimensional data analysis. The testbed system contains various dimension reduction and clustering methods with different parameter settings and allows users to easily identify the most suitable ones for their own data and analysis. In this video, we will show how users can use the testbed system. Let's load the dataset to the testbed system. The testbed system can handle several data types such as text documents, images, and pre-processed CSV format data. We now load an image dataset. Let's normalize and do the centering on the data and click the pre-process button. Next, let's first use the original label of the data and click the clustering button. And then let's use the most common and popular dimension reduction method, PCA, and click the Visualize button. This is the main frame of our system, which contains the setting panel, cluster label view, scatter plot view, and the parallel coordinates view. The parallel coordinates view visualizes the dimension-reduced results of the dataset. Each vertical axis corresponds to each of the reduced dimension, and each line represents a single data item. The scatter plot view shows two-dimensional representations of given dimensions here, and they can be changed interactively. Each number corresponds to a single data item, and its value and color represents its cluster label. We can easily see that PCA did not do a good job in dimension reduction, and the result is not very useful. The cluster label view shows each cluster label and allows users to interactively select which clusters to see. The cluster can also be highlighted in bold to easily identify the data items in the selected cluster. Let's try another dimension reduction method. We choose TSTG and use the default parameters. Now let's try another regularization parameter value. Since we have several visualization results, let's reorganize the windows and put them side by side. To easily compare two scatter plots, our system provides alignment for the clustering and dimension reduction results. First, let's align the dimension reduction results. We can now notice that the coordinates of the data items in the right view has changed so that they can be easily compared with the left view. Next, let's try a different clustering method and align the clustering results. We first choose k-means with 10 clusters and choose kernel PCA as a dimension reduction method. Next, we choose another clustering NMF with 7 clusters and choose the same kernel PCA as a dimension reduction method. Before aligning the clustering results, it is difficult to figure out which cluster corresponds to which between the two views. Once the alignment is done, we can see that it is easier to compare the clusters between the two views. Brushing and linking can be done between multiple views. If certain set of data items are selected in a particular view, the corresponding data items in all the other views are highlighted. We use different highlighting colors to identify the source view in which the data items have been selected. So if it is selected in the same view, it is highlighted with the red color, and if it is selected from another view, it is highlighted with the blue color. Original data is accessible in the scatterplot view. An individual data can be viewed by clicking the corresponding item, and the entire items in a certain cluster can be viewed by clicking the cluster centroid. While accessing the original data item, it is also highlighted in the scatterplot view. A document viewer has a similar interface with an additional feature. The document is color-coded with the user-specified number of representative keywords per each cluster with the corresponding cluster color. We can change this number of keywords to understand why the document belongs to a certain cluster. A viewer for the data type of already encoded vectors is also provided. Thank you.